Welcome to Module 3. And Module 3 is going to be um, a little bit long, so we're going to try to break it into a couple parts. Um, and it's a lot to cover, but hopefully uh, working through this, it'll illustrate how to start writing and testing more advanced console programs with C#. So it'll be a good introduction to C# and object-oriented programming. So basically what we're going to want to do is we're going to write an object-oriented program in C# that demonstrates abstraction, encapsulation, and polymorphism. We're not going to get into inheritance in this. We're going to try to keep that for a later lesson. And we'll really be focusing on classes, the static keyword, namespaces, interfaces, and some techniques to develop more effective unit tests for console applications that check what has been inputted and outputted using the console's in and out methods. So what we're going to want to do is we're going to create a command line helper library that reads command line arguments, that helps us output text, and accepts user input. You'll be able to develop tests that verify data has been inputted and outputted to the user through the command line. So we're going to develop better tests during this module. So the first thing that let's start to go over is basic ideas of object-oriented programming. So the fundamentals of object-oriented programming basically break down into these four properties: encapsulation, abstraction, inheritance, and polymorphism. Like I said, we're going to look at inheritance in another unit. So really what we're going to focus on and illustrate is encapsulation, abstraction, and polymorphism in this unit. So what are these? So the basic idea is that encapsulation, so you have to understand that object-oriented programming works with classes. So in a class, if we look at a program as like this example here, which we have a class and then everything that's inside of this class from the curly brace down is part of this class. Okay, so this is, imagine your class is kind of like a bucket, and that or a class is like a schematic, basically designed for a program, but you can imagine it's like a class holds your functions and properties and methods in the class. So basically a class has methods, which are essentially what you might call functions, and it has properties, which are attributes that or variables that are stored inside the class. So you can think of the class like a combination. It's a schematic, but it's also like a bucket that holds a part of the program together. And basically what happens in an object-oriented programming program is you have classes that communicate with each other by passing information between them. Okay, so it's passing messages and data that contain different types of data between classes through methods. Now, with abstraction, basically Abstraction is where we're trying to go from um, essentially the human readable code to more machine oriented code. So what we try to do is we try to make higher level methods and classes that make it easier for other people to use our code, and try to hide the more the implementation details from the user by abstracting it away from them. So basically you might have a class that has simple methods and actions that people understand that implements more complex operations below that, what that are called by the more simple methods. So it's like building a cake. The simpler, more human readable actions are at the top, and as you go down the cake, things get more complicated. It's like layers in a cake. Now, inheritance, a lot of times that's really where we have classes and we can put our classes together through extension. So two classes can actually be joined together. And in our first program, we're not gonna worry about inheritance. We'll work on that later because it's going to come into play whenever we make our calculator program and the statistics program at the end. And polymorphism is the other property, and we'll illustrate this pretty simply. So I'm going to show my program here, and we'll be building this, but I'm just using this as an example. Essentially, what happens is that, oops. In this program, what happens is that I have two methods here in my class. So these are two actions that can be performed by this class. Both of them are called WriteLine. But one WriteLine method can take a string parameter, and the other WriteLine method can take an array parameter. So the end user doesn't need to know which method is going to be called, because with polymorphism, the compiler is going to figure out, oh, you wanted to use the WriteLine method with the string, or if you want to use it with an array, it's going to call the WriteLine method with the array. And then in this program, polymorphism really helps to get rid of if statements, because like if you had to have an if statement, you'd have to say, oh, well, if this is a string, then call this, else do this. Really what we're doing is just letting the compiler figure it out for us. So if it's a string, it calls the create string method, and then with the create string method, we go and come down here and we have two create string methods. One creates strings with arrays, and so this one handles making a string with an array, and it returns that array, and then the other method, create string, just returns back a string. Okay, and we don't need to do any sort of if statement or selection here, because the polymorphism again allows us to figure out, it automatically knows if it's getting past an array, call the create string that takes the array type. If it's a create string, and it's a string type, we take in regular string. So the best way to start to understand these is we're going to start to write a program. And in order to do that with C#, we're going to have to learn some of the basic parts of a C# program. So let's take a look at that. So the fundamentals that we really want to cover in this section, we really want to look at data types, literals, and arrays, two data types that we use a lot. We're going to talk about namespaces, classes, and the classes that are what I would call instance classes or create objects, and then also static classes and static methods and properties, because there's an important relationship between the two that we want to understand so that our programs come out nice and clean. And then lastly, we want to talk a little bit about interfaces and how to define one, and how to, so that we can create instance objects, okay, that are properly defined. So in our readings, there's a reading about literals, and we want to do that because I can't go over every one of these literals, but we have integers, which are, you know, whole numbers, whole positive numbers. Then we have floating point, which are decimals, and we got characters, which are single characters. We got string, which is basically more than one character. We have the null literal, okay, so null means empty or nothing. And then we have Boolean literals, which are true and false. So, and along with our data types here, we have array instances, arrays of each. So we can have an array of pretty much any one of these. We can have integer arrays to store multiple integer values, can store multiple string values, double, and we can store instances of our own created custom classes. And so again, you can read more about C# arrays in the readings for this section of the course if you aren't familiar with this. One of the things that's going to come up, and we can take a look at this in some code, is we're going to see namespaces. So namespaces are simple, a simple concept, and basically what we can look at is whenever we're defining a namespace, the namespace is kind of like a folder or directory for your program. The namespace contains the classes of in a particular contains the classes, structures, interfaces. Basically, a namespace, you can have a lot of different pieces of code, and the namespace helps organize those that code into a folder so that we don't get name collision. So that if the system has something named a certain thing, and I want to name it the same thing, I can put it in my namespace, and it won't collide with the system, or it won't collide with another person's program. And so a lot of times, like whenever I make programs, I use as the root instance or namespace. Sometimes I use my GitHub ID, or I use as the namespace so that it's organized into essentially a folder of all of my classes that would be my program, or I use a namespace that's for the actual program. Basically, namespaces can be called anything, but you want to think about how it can be used so it's not going to collide with anything. Just like you don't want to have two directories called the same thing in a file system. You don't want to have two namespaces called the same thing. And that goes the same thing with the files and such, or parts of the program that are inside the namespace. So you don't want to have two classes called the same thing in the same namespace. So two big things that we want to look at in this program is really like a sort of a pattern to keep our programs nice and clean, is that we have classes that are what I call instance classes, or create objects. And those objects, basically, if you can go to the way I like to think about it is, if you can go to a store and buy something like a calculator, or it basically contains two things. It contains data and actions. We're going to want to make an instance class. Instance classes stay in memory. You're going to come into this a little bit later. We're going to have, whenever we get to working with data, we're going to have data structure, which is a part of can be part of a class. And basically what we do is we sort of divide up our program into instances and what we're going to talk about next, which are statics. So statics are actions usually, or constant properties. They're good for making your code reusable. And a good rule of thumb that I like to use is, basically, my instance methods are just taking input, and then they pass that input into a static method which will perform the action or set up, or could have a constant. Mostly I use them for actions. Statics help for making your code more reusable and helping to implement abstraction to make the code more readable. And statics are used a lot. So like a lot of times I think that, like, people call it object-oriented programming, which is sort of the idea of real-world objects, but it turns out that a lot of your code that you write is going to be inside static methods, and it's going to use static properties. Now, one of the things that goes along with instance methods, or instances, classes that can be turned into objects, is the interface. Okay, so if we take a look at the code here, I wrote an interface for what I call iConsole. And my iConsole interface, and in our own program, this is sort of like my Scratch program. We're going to build something better than this. But it illustrates that I have an object called console output. Oops, sorry. I have an object called better console. So I make a thing called better console, and in better console, it's got to implement the write line method here for taking in arrays, and a write line method for taking in strings. And that's actually, if I go up to here, this is this method and this is this method. So if I'm going to instantiate a class, turn it into an object, I'm going to write an interface for it. If I'm not going to instantiate it, I use static classes and static methods. Okay. So that I don't have to instantiate it to call the function. So it's basically like, the idea behind this little program I was writing is that the better console is just a better way to interact with the console, and in this case, this one only does right line. And what you can see here is like what I was talking about, where I have my console that I instantiate up in my program. So I'm going to go look at my I'm not going to whenever I instantiate this inside of the application, I instantiate better console and make a new object. We can take a look at that in input tests. So here, oops, sorry, output tests, where I'm instantiating the new console object with better console. So I'm making basically a property here in my class called console, and it's filled with the better console object or class. And then what I'm doing is able to do like console, oops, console.writeLine. And this console, if you look at it, it's actually the better console object. So we're going to get into updating our test methods, and you'll see how that works. But the gist of it is that when I'm going to instantiate something like better console, I'm going to have a class here, better console, and it's going to implement iConsole as the interface. And then the interface says that it's got to have these two methods in order for it to actually work. Okay, so we'll start writing a program and we'll step through this, and that's what we're going to do in the next part of the video when we're actually going to build the program. So what I'm going to do is I'm just going to stop here, and then we're going to have a part 2 of the video, which is going to be actually building the program and making some tests. So I'm just going to stop this